APIs are used in so many Salesforce implementations and projects. It is challenging to know when to use which API and to keep track of all the new APIs. In this video, Andy Fawcett will discuss Apex APIs such as platform events from the Batch API, errors on S-objects, and much more. Welcome to 100 Days of Trailhead, where the tech community comes to learn Salesforce, learn tech, get inspired, and invest in ourselves. We are your trail guides, here to support you on your learning journey. We release videos weekly. Hit the subscribe button so you don't miss a video. In the description below, you can find links for everything we mention in this video, as well as books and resources we found useful. Visit our blog, 100daysoftrailhead.com, for other helpful Salesforce and tech content. Do you ever wonder what APIs are best for specific situations? In this video, Andy Fawcett covers Apex APIs with specific tips to help you on your projects. Andy is a Salesforce MVP who is a former FinancialForce.com CTO and currently works for Salesforce.com in product management. Your quest, should you choose to take it, is to journey with us to learn about Apex APIs. Your quest begins now.
So at number 5, I've got firing platform events from Batch Apex. This is essentially a feature, and I've included links at the top of each of these for further reference. But this feature is essentially ability to capture errors that are emitted from a Batch Apex, whether it's in the start or in the execute or in the finish phase of a Batch Apex job. All you need to do is implement this interface. It doesn't actually have any methods, and that'll trigger the platform to know that you want to receive, or somebody wants to receive, those events whenever any errors occur from either of these methods. And that also includes unhandled exceptions, such as those relating to limits and such like. So this sample code is processing some orders and creating some invoices, and we've got a rather evil looking method here that attempts to create some exceptions, including some unhandled exceptions, such as those around limits. So this job executes, and when errors occur, this platform event fires. This is the Batch Apex error event, and it's a standard platform event, so it's not a custom one you have to create. And this is my handler for it. It's pretty much derived from the documentation. The documentation queries the async Apex job, the Batch Apex class. It does that so that it only processes events for the one that we're interested in, which is that batch job we were just looking at. And it simply, in this case, updates the originating order records with the appropriate exception type and message, so that an end user or an admin can go and review those and rectify any problems. Of course, you can do all sorts of things in this handler since it's Apex. You can also subscribe to this event using Flow as well, and Process Builder. So it's good for those kind of declarative subscriptions. Number 4 is the request class. It's a relatively new feature, but it has a couple of things that I'm going to cover in 4 and 3. The first one is the request ID, and again here are the links as well as some additional information and how it relates to event logs, for example. So it's pretty simple to use. Get recurrent and then call get request ID gives you the request ID. It's the same request ID we use in the event logs product, and also you'll see in debug logs. From an Apex point of view, it's also pretty useful to correlate asynchronous processing. So this example, imagine you've got a Lightning Web Component, it's an Aura-enabled event method here, and you're creating custom metadata as a native API for doing so. And it's asynchronously implemented, so you enqueue that deployment. The callback can use the request ID as a kind of correlation ID, so the client knows that the response from the callback is specifically for this piece of work and not anything else being done by another user or another request. So we store the correlation ID in our handler, which is simply an implementation of the metadata deploy callback. And inside that, I've not obviously completed the logic here, but you can go and invoke store some of that callback information in a custom object, or if you wanted to, you could fire an event, and of course passing the correlation ID forward in that event allows any subscribers to determine whether it's an event applicable to them or anybody else. So Interesting use of the request ID as a correlation ID, both in terms of asynchronous processing, but also in those event logs and in the debug logs, you'll be getting a much more overall view of what the processing is undertaking on the platform, both your code and any events that are being captured by the event log system. So that was number 4. Number 3 is again using this request class, but this time using the quiddity value, which tells us when what type of request is invoking the Apex code. That might be a Lightning component action, it might be some Visualforce code, it might be a scheduled job, might be batch Apex. There's quite a number of places, as many of you know, that can be invoked from Apex, that can invoke Apex rather. So how could we make the use of this in a use case? Well, imagine we've got this piece of code here, it's processing some new orders, and it's in an Apex trigger. And Apex triggers generally are, by design, unaware of the context in which they're used, but in some cases it is helpful to know whether you're in a bulk API load situation or whether you're in an asynchronous situation, or even if you are in a trigger situation for some shared logic, whether you can actually do certain operations which are sometimes blocked due to limits. So we want to try and keep this code fairly sane looking, but avoid all sort of if then else logic when we're comparing the value of quiddity to know what context we're in. So this pattern breaks down the logic into a basic abstract class that represents field value setting on the orders. Maybe we're generating some invoices, and maybe we're calling an external system to pass back that ID in Salesforce that represents the order. And this might be an example of such implementation where you're setting some default values, generating those invoices from a batch of orders, or even updating an external system with some callouts. Now, given the number of contexts I just listed there, if we were in a bulk API situation, we may want to choose to defer some of the heavy duty processing, such as generating orders or even some callbacks to external system until a later date. Maybe an asynchronous scheduled job might handle these post-process. So this particular class extends that base ordering class and does bulk API processing and customizes that logic effectively. Likewise, inside the trigger scenario, this trigger order processing class extends the base order one and overrides the generate invoice and update external order management system with appropriate logic that you'd see it based on a trigger context. So how does all this work? Because that logic that I looked at earlier didn't appear to know anything about those contexts, and that was the design, the idea. We want to make sure this is kind of agnostic of those contexts. So the order processor property is kind of the thing that does the magic. If we scroll down to the bottom of this class, we can see that the order, it is actually a property, a static property, and the getter for that is resolved by using this quiddity value. And then there's a switch statement that says, well, if I'm in synchronous, which is a trigger mode, then I'll use the trigger implementation, this one for bulk, and of course, if there's any other context that we're not particularly concerned with customizing, then we'll just use the base order processing. So this is kind of a neat way of kind of keeping your code fairly sane, making it extensible for different contexts if you need to modify your code for different scenarios in different use cases. So that also gives us the ability to emulate some of those environments, because since we can inject the quiddity value into the context of that class for testing purposes, it means that we can, for example, emulate the bulk API logic that we just looked at without actually having to think about how we can emulate the bulk API itself. It's kind of a unit test for bulk API related logic, which is pretty neat. So number two relates to notifications sharing to the end user. This is a relatively new feature and now has an Apex API. So we're going to go and create an order as part of this demo. It's a special order. We want to notify users that it's arrived and make some kind of noise about that because it's a particular order of a significant value, for example. So this sample code creates that order and creates this custom notification type, and then eventually sends it using notification.send, and we're using some metadata that was created earlier under the setup menu called notification types. So I can go ahead and run this sample code by just executing this snippet of Apex code in the comment here. And then if we go to the window with my org open, I can see the bell icon, which is where my notifications arrives, has that notification in it. And if I was on a mobile device, this would show on my device notifications. If it was an Apple device, for example, the mobiles are available, mobile devices are available, then I would see the notification on the lock screen. So that's pretty cool because as an Apex developer, I don't really need to know too much about mobile notifications or anything really. I can just use this Apex code and it'll send those notifications. As you can just see here, they're context aware as well, which is pretty cool. So I was able to click on that notification and it would take me directly to the order. So that's a great feature available, and that's number 2. So number 1, I've chosen to go with the ability to be more dynamic about how you raise errors on S-objects. So for those of you familiar writing triggers or even other parts of Salesforce, maybe Visualforce pages or even Lightning components, you can set errors on the S-object fields or on the S-object, and those filter through into the various user interfaces. Historically, you've had to be very specific about the field that you need to set, and it's also been hard to get the errors back out when you want to write tests unless you need to insert those records, which is expensive if you're writing a lot of tests for different scenarios. So the enhancement that's been made here is, first of all, we can use a dynamic, or in this case literal, string. We don't have to use the actual hard-coded value, which you'll see why in a moment. That's quite useful for writing like library functions around error handling. And secondly, I can get hold of those errors dynamically from that S-object type, just directly from the opportunity that I just created here. I didn't need to insert that opportunity or even set any other values on it, so it keeps it really lean from a unit testing perspective. And you can see like these asserts run here, and I'll just run that just to prove that logic's working. So it's a very basic demo of that. Didn't throw any particular errors in the console there. So if we were to look at how we typically do error handling in the past, you can see that when I'm setting errors, like the add error here, I'm being very specific about setting it on the description field. There's a whole bunch load of logic here around querying related accounts, comparing the old and new values. It's very hard to actually see the validation amongst some of the kind of boilerplate code that we typically have to write. Now, there is a library that's linked to in the links at the top of this particular demo here, which is an S-object field validator. It's an open source library, but the idea is it kind of proves that with the advent of this dynamic ability to add errors, you can create libraries that really cut down on some of this boilerplate code and allow you to focus on writing the actual validation logic itself. So this is kind of a bit of an experiment in how you could write kind of like a generic field validator library. But nonetheless, it demonstrates kind of the ability that dynamically adding field errors offers. As obviously you've got this testing capability as well.
And with that, we're at the end. What API did you learn the most about in this video? Comment below. We would also love to hear what video topics you want us to cover in future videos in the comments. If you've made it to this point, we want to take an opportunity to say thank you. Since you've stayed with us, let's listen to Andy as he provides an API bonus tip.
Well, so this is my bonus item, and for that I've chosen to use transaction finalizers. It's in pilot at the moment. We'll be going into beta in the spring release rather. And the idea with this is that if you're again using asynchronous processing, you want to know more about the outcome of that, if it's errored or even if it was successful, or even do some more logging capabilities. And while it's been possible to do that to date, it's always been difficult to do that, particularly if there's unhandled exceptions or you needed to roll back some transactions and yet still log some output. So finalizers basically run regardless whether your queuable failed or succeeded, and you get to specify the code that executes in that situation. So I've emulated 2 jobs here, a job that starts job 1, I give it a workload. It's a very simple demo here, just give it the value of 10, and the second job has a value of 201. And that goes on to control in the job itself what work is undertaken. So I'm just using it, just playing a kind of a little evil bit of code here that obviously is not bulkified, but I'm trying to tease out the unhandled exceptions behavior of this feature. So the key bit of logic here is this finalizer. system.attach finalizer. When you do that, this piece of code that's inside this class here will get executed when this completes, regardless of whether an error occurs or not. I'm also using it to capture some state, like some log messages, so I can get those output as well. And these will obviously get captured regardless of whether an error occurs, because they're kind of stored in memory right now. So let's have a look at that bonus finalizer. And you can see that, first of all, it checks whether or not the result of the queuable was success or failure, and then adds an appropriate message. And then I'm using that notification technique I showed you earlier to send a notification to the UI or the mobile device. You could, of course, log, and there's a great example in the docs of how to log this to a custom object if you wanted to, or even send a platform event. So let's just quickly go ahead and run this example. It's also worth wanting to point out there's a really cool example for those of you familiar with Node.js around promises. This is a way of kind of chaining asynchronous processes together in an effective and reliable way. It's worth checking out the link there that talks more in depth about how to use this feature in that context. So now we can see the two notifications have appeared. Here's the one that failed. We got our limit exception, so it proved that the logic was actually able to capture unhandled, up until now at least, unhandleable exceptions. And then this is the success scenario where it completed the work. Okay, so that basically wraps up the top 5 and a bonus item. Hope everyone's enjoyed that. Thanks for watching.
Thank you for spending time with us. Please like and subscribe to our channel because we share weekly content to support your tech and Salesforce learning journey. Don't forget to hit the notification bell so you don't miss a new video. We also handpick these videos which we recommend you watch next. Connect with us on Instagram, Twitter, Facebook, and on 100daysoftrailhead.com, all of which are listed below. Thank you for learning with us, and we'll see you back tomorrow.